Thanks for having me. And this is a talk about how to apply AI to software testing. I don't know if you recognized, right now there's a bit of an AI hype. So everybody's talking about AI. Everybody thinks that AI is a new shiny thing that can be applied to everything and should be applied to everything, and that solves all our problems. And right now in software development, testing and quality assurance in general is the biggest bottleneck, like the biggest pain point. What you can see is that 99% of the companies that were surveyed said that they face some kind of challenge in the area of software testing. And the Forrester research identified testing as the major bottleneck that's holding back development and slowing down the release of new features and new software. So it kind of makes sense to say, okay, if we have this problem here and we have this new shiny tool, AI, let's see how we can use AI to address that problem. If you think about what we have in terms of processes in the software development realm, then a typical process could look like that. So you have a ticket systems where the bugs and the new features are documented. Then you have the development where the new features are implemented and the bugs are fixed. Those changes then are released to a testing stage where they are either manually or automatically tested or both. And then they are released to production where tickets are created. Also during testing, tickets are created, so all of those information flows back into the ticket system, and also maybe we get some test data from the production system to have realistic test scenarios. So if you think about that, then where could we use AI to enhance and speed up that process? Actually, it turns out there are quite a couple of situations where we could use AI. So for instance, we could use AI for bug triaging. So if you have a large ticket system, like Microsoft or Facebook or any large company, then you have like hundreds of bugs that are registered per day. And it turns out that about 25% of these bugs are duplicates. So if you have a system that detects those duplicate bugs, then you have an instant saving of 25% of effort. Then also defect analysis. Like if you have a bug, someone has to look into the ticket, understand what's wrong, and then try to fix that. So first and foremost, you have to understand what the underlying problem is. And you could use AI to generate a root cause analysis to tell you what problems are related, or what variables, what software components, what pieces of the code are related to the defects that are documented in the system. Then if you release a change, you probably have or depending on the system, often you have the situation that you forget to change something. Like you have code duplication and you change one part of the code, but not the duplicated one. Or you change multiple parts of the system that interact with one another. And you could use AI to detect anomalies in those changes. Also, for test data generation, this is very crucial, like with GDPR and everything. Test data is now depending on the situation, oftentimes difficult to attain. And you could use AI to just generate that test data. Then test selection. If you have a lot of test cases that you want to execute either manually or automatically, then you can use AI to select which test cases you want to execute. And also test generation, like this is what I actually want to talk about. How can you use AI to generate new test cases and to find defects? So all of these cases are very valid and very interesting, but for this talk, I'm now going to focus on test generation, optimization, and maintenance. And this is very, very straightforward. Like if you ask a developer what testing looks like, he paints a picture like that. So he says, okay, all the complexity is inside of the software. And the tester, the task of the tester is quite simple, actually. The task of the tester is just identifying components that he wants to interact with, then interacting with them, like clicking and entering text, and maybe some test data maintenance because of, like in that case, username or password. But that looks like the task of the tester is rather simple, and therefore could be automated using AI. We'll come to that later. So yeah, the general assumption is should be easy to just use AI and test the software and find all the bugs, all the defects. However, there's a problem to that. So if I give you this software and I ask you, is this value correct? Then you would have to say, you don't know, right? Because you don't know the software, you don't know the data that went in, you don't know how it's configured, so you have no chance of guessing whether that value is actually correct or not. And frankly, the AI is in the exact same situation. The AI would have to understand your software in depth in order to understand whether the value is correct or not. This is called the Oracle problem. And the reason why it's called the Oracle problem, I mean, Oracle problem is coming from the Greek methodology. That's a pretty fancy name for an IT problem. And I don't know whether you ever thought about why they came up with such a fancy name for such a straightforward problem. And the reason for that is, if you could come up with an entity, an AI or any other system, that for any given software in general could decide whether the result is correct or not, well, then personally, I would create a 3-line program that whatever I tell it, it returns no, just no. And then I could ask it, does God exist? And then the entity, the AI or what have you, would have to know whether God exists in order to decide whether my 3-line program is correct or not, right? So any given problem, any problem that humanity has, foretelling the future, deciding complex political arguments, can be turned via that technology into the Oracle problem, which means that the Oracle problem is the hardest problem there is. If we could solve that, we could solve all other problems as well. Okay, but maybe let's not aim that high. Maybe we don't shoot for the moon. Maybe we have a simpler problem. We don't want to know whether God actually exists. Maybe we want to know whether our text program is correct, right? So we have a simpler problem. Okay, example. Let's assume the question is whether 1 minus 2, what the correct result of this calculation is, 1 minus 2. It's math, so it's well defined. Everybody knows it. Who's in favor of -1? Okay, that's good, because that's mathematically correct. However, if you create like an Amazon, you know, a shopping cart application where you can buy things, and you have a gift certificate that you give to the clients, to the customers, and they use that gift certificate, then maybe you don't want to pay them back the rest amount, right? If they buy something that doesn't use the complete value of the gift certificate, then you don't want to pay them back. So in that situation, it should be 0. However, if you're dealing with, say, time, with hours or minutes, then the situation is completely different, right? Or if you're dealing with calendars, like dates, then it's something in that regard, right? And if you're dealing with degrees Fahrenheit, then you might know that there is no minus value. Like there's a 0 point, and it can't get below that. So if we have that calculation, and you want to know the value of degrees Fahrenheit, then this should actually be an error and raise an exception. And as you can see, all those outcomes are correct for such a seemingly trivial and straightforward question what the correct outcome of 1 minus 2 is, right? So in order to decide which of those cases applies, you have to understand the system and you have to know what you're doing. And if the AI gets smart enough to do that, it kind of doesn't make sense to have it test the software. If it gets smart enough to understand that complexity, you'd rather have it generate the code and manually test the code than manually create the code and have it automatically test it, right? Okay, but we're back to that. So assume that testing is easy, because testing is just, as the software developers see it, testing is just identifying objects or components you want to interact with and doing that. And as you just saw, that's not the case. Testing is much more complex, because in order to understand what you're doing, you have to understand and navigate the complexity of the underlying problem. So you have to understand what the software is actually supposed to do. And if you're not just testing the code that has been given to you, if you're a very, very good tester, then you not only challenge the implementation, you challenge everything else. So you say, okay, maybe the process could be improved. Maybe the user interface could be improved. Maybe we should have a completely different product to start with, right? So if you're a good tester, you not only challenge the code, the implementation, but you challenge everything else as well. And this is even more complex. And if AI can do that, well, then I guess we're out of jobs anyway, right? If you can read it, so this is a create account page, and it on first sight it looks legit, it looks correct. But if you read the text, it says password is being used by user Rovaldo37189. Please choose another password. So, you know, on first sight it looks correct, but if you think about it, this is actually a very severe data breach, a very severe security issue, and AI would probably have a hard time identifying that issue. Because on first sight, it looks correct, so it kind of seems legit. Okay, so I said the Oracle problem is keeping us from actually using AI for testing itself, like directly using it to test software, to find the bugs. But maybe we can do something else. Maybe there's another possibility here. Because if you think about it, when people wanted to fly, that was their role model. Like they thought, birds fly. If we mimic birds, if we put wings on our arms, then we can fly at some point. And as you all know, this doesn't work. So the wings would have to be much bigger, and we would have to be much lighter. So this doesn't work. However, we learned to fly. We learned the underlying principle of aviation and applied it in a different way. So we abstracted the problem and solved the problem in a different way than nature does. And actually, this kind of enabled us to even go further than nature, because we can now fly much faster than any bird, right, or any insect, because we understand the underlying physical principles and apply them in a different manner, allowing us to do much more than the natural thing we want to imitate. Actually, it even allows us to fly to the moon, which we did, right? So maybe we can do something similar here. Maybe we can understand how to use AI to solve the problem, but not solve it directly as we do, as a human does, as we do it manually, but solve it differently, have a different approach. Okay, the idea here is that we do one thing different. We don't define the outcome, we approve it. So the idea is that you can't get rid of manual testing, you can't get around the Oracle problem. But like 80 to 90% of the effort spent is repetitive testing, like testing something that has already been tested before and that has already been approved, and test automation that just doesn't work that well, right? Maybe we could use AI there to address these problems. And then, if you think about test automation and regression testing, then we're in the whole different situation, because automated tests are not tests. Let me repeat that. Automated tests are not actually tests, because a test, if you do a manual test of the software, you try to find a bug. You try to find something that's odd, something that doesn't quite make sense, right? So you try to find that. If you automate a test, you rarely go and say, oh, I created that test, let's see if I execute it 3 times, what bugs it will find now, right? That's not the purpose of test automation. The purpose of test automation is to guard against unintended changes. So you assume that the software you have at hand kind of is okay-ish, maybe, that it's okay, that it's right, and then you just want to make sure that it doesn't break. So if you change something here, that below shouldn't break, right? And this is what you use test automation for, to guard against those unintended changes. In that regard, test automation is more like version control. Because we have that paradigm, we have that software that helps us manage and control changes to software. It's called version control. You use Git, you use SVN, you use all those tools. However, we still need testing on top of that. Because those tools, the version control systems that we have today, they answer the question, where has the code changed? However, it turns out that code is not software. This is the code, but this is not the user experience. This is. So you have to execute the code, You have to instantiate all those variables and classes. You have to load them. You have to load the configuration and the data using the runtime system. And then you get the software that user experiences. This is what he gets. But this, on the left, the code, this is what we control today using version control. And this means we're having a gap. We want to know, we control where code changes, but we actually want to know where the software changed, right? So for that, to close that gap, we use tests. This is also the reason why you need to execute the tests. Otherwise, they won't tell you anything. So you have to execute the software, and you have to execute the tests in order to find those unwanted differences. However, the tests we currently use are not well equipped for solving or for addressing that problem. If we assume that automated tests are version control, then we can use a different paradigm for automated tests, which is called golden master testing. And now I want to give you a quick demo, what that actually means. So this is an open source product, an open source software that you can directly use. As you can see here, it's a Selenium test. Who has ever used Selenium? A couple, okay. So this is straightforward. You execute this test, and what it does is it opens a login form, and then username, password, clicks login, and then checks whether we successfully logged in. And it does so by checking whether the word success is displayed after clicking login. So this is what this test does. So now if we change the CSS, just changing one simple character, as you can see, the website now is essentially broken. For any user, the website looks broken, but this is not what we check. We only check whether success is displayed, so the test is still green. If we now, for instance, change the ID of the elements that we want to interact with, the user doesn't care about those, right? They are not displayed. The user doesn't see them. However, our test needs them to identify the elements that it wants to interact with. If we change the ID, the test breaks. This is essentially the opposite of what we want. We ignore important behavior, important changes, and we break on irrelevant ones. Maybe we can change that. So this is, as I said, this is open source. You can just go and download it and use it. All we do is we wrap the driver in a reject driver, and it's the same test. It's doing the very same thing. Now, let's change the CSS again. Now, as you can see, the website is broken again. So the CSS is all changed, and for the user, it looks broken. But this time, the test tells us. This time, the test says, oh, there are a lot of differences. Maybe go and have a look at that. And what's even better, if you now change the ID or delete it, as you can see, it's the same test, so we need the ID to identify the element, right? However, we deleted the ID on the website, but the test still executes. So it still finds the correct elements and executes. This is what we would want, right? There are two challenges for golden master testing. Golden master testing means essentially we create a copy of the website and compare to that copy. So that means we have two challenges. One is noise. Well, if you know version control system, you have the same problem there. Imagine Git without a git ignore file. It will show you all the log files, all the class files, all the artifacts that your build creates. So we are using git ignore to get rid of that. And if you think about, if it's a version control system, then the assert statement actually a deny list of changes. What you're saying with an assert is, this thing can't change without the test failing, without me noticing. So whenever that changes, I want to know about it. And then I still can update the test, right? So, but I want to know if that changes. If you go for an ignore list of changes, what you do is you say, I want to see every change except for that. So whenever that changes, I'm fine with it. I don't care. And it's a bit of a grayscale scenario. So you have something on the left where if you have no asserts, you check for nothing. If you have no ignore file, you check everything. And you would like to be somewhere in the middle, right? And now the question is, how do you want to approach that situation? And thing is, there's an example from Google. So apparently at Google, if you change something, like if you change a component, then it gets marked with a dancing pony. And if you're a tester at Google and you see the dancing pony, you know that this thing has changed and that you need to thoroughly test it. However, it turns out that at some point they forgot to remove that marker. So the clients, the users, had those dancing ponies on their screen because nobody created a test that said, is there a dancing pony on the screen, right? Which means that you can create an assertion for something that you don't expect. You only can create an assertion for something that you assume could at some point happen. So going from the left-hand side, from the from the right-hand side, from the deny list is more risky because you have to put all those assertions there. Going from the left-hand side, on the other hand, you are being shown all the changes that you didn't ignore. So if something unexpected happens, you are being shown it, and then you can decide how you want to handle it. And also in our experience, you usually want to check more rather than less. We call this a Git for the GUI, and like the git ignore file, we created a file that we call recheck ignore, where you just can specify what you want to ignore. And if this would be pixel based, then you have these. Can make that bigger. So you have these two websites that are quite different, and if you compare them, well, we are telling you that everything changed. But now you can use filters which have the same mechanism as a git ignore, and you can say, I want to ignore positioning, I want to ignore styling, like fonts, colors, everything, and invisible attributes. So we show you those 4 things that are relevant changes. You see how different those 2 websites are? You can boil that down to what you're really interested in, which means that you can use the same mechanism if on your website to boil down to what you actually want to see. The second problem that golden master testing has is redundancy, which means that if you have 5 tests testing the same website, or 50, and you change the logo, all 50 tests will now fail. You can use those tools. These are also open source to remove that redundancy. So you just say apply, and all 5 or 50 instances of the changes are applied. Now, what you saw earlier about the idea that changed. Well, as I said, golden master testing is essentially creating a copy of the website. So if the ID changed, or the name, or XPath, or whatever, we can just go into the copy of the website that we created and find the element there. And there, the ID still exists, right? So we find the element, we create a one-on-one assignment of all the old elements to the new elements, and we find a best match and return that. And with that mechanism, we can make the test execute, although the ID now has either changed or is removed. It still works. And as I said, this is open source. You can just go and download it and use it. What has all of this to do with AI? I want to ignore that. What has all of this to do with AI? Well, it turns out that this circumvents the Oracle problem. Now we don't need to know whether something is correct or not. The AI doesn't need to know. The human that's testing manually still needs to know, but the AI doesn't need to know. We can just create copies and show the differences. If regression testing is version control, this is how you circumvent the Oracle problem. Now you can use the infinite monkey theorem. I don't know if you know that theorem. The idea is a monkey hitting keys at random on a typewriter for eternity will eventually create every string, like every possible combinations of characters will be created, and one of those combinations of characters will be Shakespeare. So in eternity, the monkey creates Shakespeare. It just takes very, very long. And we now do essentially what we now do is we remove the we remove the typewriter and replace it with the computer and let the monkey test. Now the monkey executes our software and finds all of those execution paths through the software. And I brought a monkey with me, so this is a very simple example. It just clicks on random points, and this is how it looks like. So now it tests the website, and as you can see, it just clicks randomly, and this guy will find bugs. If you let it run long enough, it will find bugs and crashes. And it's very cheap, right? As you saw, it's just 15 lines of code. Everybody can do that. It will find you bugs. However, the problem is this is not very intelligent right now. For instance, if it clicks on an external link, it will stop testing your website and start testing the internet, which is probably not a good idea. But it kind of works. So we can go from, and there are open source tools that you can use. But you can go from there and improve that. So we start with a very dumb monkey and make it more intelligent. Like, it looks like that, but what we want is something like that. So how can we do that? Well, first step is we give it context. So we tell it that it's not clicking on random pixels on the screen. We tell it that it should click on links and that it should click on text fields to enter text, stuff like that. And if you execute this, it's much more, as I said, it's much more intelligent. It can already, kind of understand what it does, and it's very easy to expand, to extend. So you can, for instance, say, if you have a login screen, then you first need to log in. If you leave your website and start testing the internet, you can detect that and go back. So it's much better than the dumb monkey we had initially, but it's still not really intelligent, right? There's no AI in there. Well, and the problem is, for instance, if you have a complex screen, then it's hard to get through the validation. Like even creating a valid email address or a valid birth date for that guy is hard. And if you have like a process that you want to follow through, it has problems detecting how to get there. So I want to make an analogy here. As you saw in the talk before, if you want to use AI for autonomous driving, you have to detect a lot. You have to detect the signs, the traffic lights, the obstacles, and all of that in real time. And frankly, we can't do that now. This is one of the reasons we don't have cars driving around now. But we can do something easier. So if the problem is too big, we can select a smaller subset of the problem and solve that first. And this is what, for instance, Google did with their project. So if you have all of that data, if you have all of the pictures, and you can analyze that offline with as much time as you want, then you know how fast you can go, you know where to turn, you know where you are already, and then the problem gets much easier. You know there are a couple of traffic lights in the image. You just need to find the one that's for you and find whether it's red, green, or yellow, and that's much easier. So we can do the same with the AI. We can give it like the big picture, the user, the happy path, user story, and then the AI can use that and create variations of that. So it can do other stuff. It can test what happens if I click back in between, if I enter an invalid birth date, if I enter a birth date in the future, stuff like that. And it can even, with that, it can even detect differences that a human can't, if you allow it to analyze the source code. So, and on top of that, now you can add even real AI, which means you can have a neural network that learns how a typical user uses a typical software and then decide which buttons to click. So what the AI learns essentially is if a button is bigger, it's more likely to be clicked. If elements are close to one another, you want to use them together. If like it learns, UI, UX design principles that typical humans apply when they use a typical software. And on top of that, you can use a genetic algorithm and combine the two, so you can give it just a couple of training examples, because for a neural network, you need like thousands of examples, right? But for a genetic algorithm, you need just 1, 2, 3, 10, 50, just a couple. So you record those, and you say, okay, this is how I log into the system, this is how I use the ordering system, this is how I enter a valid credit card, stuff like that. And then combining those, we get a very strong AI that can actually execute your software. And as I said, you can train it with real-life examples. So now we automate what is easy to automate, right? So the easy part, the clicking and pointing and entering text, this is actually the easy part. We can use AI to solve that problem. And we can use another technique to circumvent the Oracle problem and have AI automatically generate test cases for us. Automated test cases that you can use in your CI/CD environment and execute like every night or every week, whatever you want. So this is how the overall process looks like. And this is already being used. Like in Facebook, you have Sapiens, which does essentially that. So they use internally AI to execute the apps. And they even go one step further, they generate fixes. So if you have a crash, like if a null pointer exception or something, the AI in Facebook can even generate a fix for you. However, unfortunately, this is not a product that we can use. So it's just inside Facebook. So, yeah, that was the talk. Are there any questions? Do we have time for questions?
Thank you very much. У нас есть время для вопросов. Please, we have some time to ask questions to the presenter. If any questions?
Okay.
One question here.
Thank you. I want to ask you, how do you deal with a lot of test failures with this approach? So you use automatic testing past scenarios, generating scenarios? What are you doing? How do you analyze failures?
So there are two types of failures, like the real failures, like the software is broken and the test fails. Then those are actual, actual bugs that we find. But I think what you're referring to are the failures if the software is not actually broken, but the test still fails.
Yes, I think that there is a lot of noise.
Mm-hmm. So that is what we use the git ignore, the recheck ignore file for. So you can specify very detailed what you want to see as differences, and you can say I want to see a difference, say of a font. I want to ignore the font but not the text, or vice versa. So you can very specifically define what you're interested in. And our experience is that after a couple of like hours after adapting the ignore file, you're good. Like you don't have false positives anymore. Does it answer the question?
Yes, thank you.
Thank you.
Any more questions? Yes, please.
Yes, thank you for your speech. So maybe a couple of questions. One question, you were mentioning some cases with web interface testing and so on. So my first question, how agnostic is this approach to the problem? So what type of software or what type of problems we can test with this approach? And maybe a next additional question. So is it approach allows us to let the system to learn somehow? Yes, you mentioned some supervised learning, but what is the basic idea of learning of this system, of training the system? Yeah.
So the first question, generally you can use this to test any type of interface. Like the user interface is very easy to test because it only has primitives. Like you don't have, with an XML, you have to pass the XML validation. Like it has to be valid XML, right? Typically, for a user interface, it's very easy. You have just clicks and text enters. So this is much easier to test. But in general, what monkey testing is some sort of fuzz testing. And with fuzzing, you can also test XML interfaces. In a sense, you can use the same technique for any technical interface, but not unit tests. So this is something entirely different. An interface is a defined scope, a defined thing that you can test against. So if you have an interface, in general, you can apply that. But we implemented this first for web. And then the second question, how you train it. So what we do is essentially we use Selenium, and there's a Selenium IDE. So you can record test cases just by using websites. And if you have existing Selenium test cases, like existing automation, then you can use that as well to train the software or train the AI. And as I said, we deliver a pre-trained neural network that learned how a typical user, typical human, uses a typical software. And for anything that's not intuitive, like if you need to know valid username, password, valid transaction number, valid item number, valid whatever, something, a credit card number, something that the AI can't come up with on its own, then you need to train that and give it to the AI, and it will be used within the genetic algorithm. So a genetic algorithm mixes different test cases and recombines them, so there it will be used. And as I said, the deep neural network, or the neural network, will learn how clicking a bigger button is more likely than clicking a very small link down below that nobody sees. So this is what the neural network learns. Does that answer the questions?
Thank you.
Okay.
We have time for one more question, if you have. Yes, please. Девушка, там человек первее поднял руку.
Okay, thank you very much. Do you have any example or probably any numbers, any characteristics, how this system improved already existing classical approaches of the testing?
Okay.
In hours or in efforts, I don't know.
So we don't, that's actually one thing we want, those numbers, but we don't have them yet. So from gut feeling, you can, depending on the project, you can save up to 50%. But usually what we see is that like there's no tester that's being let go of. Instead, the testers do other things. So it's very hard to measure. And we don't have reliable numbers for that. But gut feeling would be around 50%. Does it answer the question?
Yes, thank you.
Thank you.
Okay, I think there is another opportunity to ask questions near this room after the presentation. Let us say thank you again for the presenter. Thank you.